Hey, good morning, everyone. Today is Thursday, March 26th. Today, I'm going to be here and I'm going to help you a little bit with uh, some problems. I'm looking at page 691 in your math book, which is lesson 33. You may not be here yet, so you can always wait and watch this when you do get there. I'll put that lesson and page number in the title of this video, which I'm going to be posting up on my YouTube channel instead of Dojo. So yeah. Help you again? Yes. Yeah. There's that. So the problem here that we're going to be looking at in your book, okay, in this develop section here, it says the scouts are making model vehicles. They have a choice of making a model plane or a model boat. The materials for each plane cost $2. The materials for each boat cost $4. Write two patterns to show the costs for making 0 to 4 types of vehicles. Graph the points in a coordinate plane to show the relationship between the corresponding terms. So, let's go ahead and start here looking at the relationship in the pattern. And so we're going to use a table up here to start looking at these patterns. Now, it talked about corresponding terms. Well, what is a corresponding term? Well, a corresponding term are terms that have the same place or position, I guess, in relationship to the patterns here. So if we have two patterns here, we're going to say V is for the vehicle, P is for the plane cost, and B is for the boat cost. So naturally, if I have zero vehicles, it costs me nothing for planes, and it costs me equally nothing for the boats, right? Remember, the planes cost $2 in materials for each plane you make, and the boats cost $4. But so when we make one vehicle of each, so when we make one plane, it's going to cost us $2. When we make one boat, it's going to cost us $4, correct? So our goal here is to project this out so we're making 4 vehicles, right? The cost of 4 vehicles for each one. So I'm going to go and finish this out 2, 3, and 4. Obviously, we can continue going on, but this is all we need to do for this. So again, if 1 costs 2, then 2 would cost 4. And we're just going to follow this pattern out. 3 would cost 6, and 4 would cost 8. Easy peasy. Okay? Next, for the boat, if 1 boat costs 4, then 2 boats is going to double that to 8, right? Okay. 3 is not going to double. I shouldn't have said double, but the idea is that one did double. This is going to be 4 more, so this is going to bring us up to 12. This one's going to bring us up to 16, right? Okay, making sense? If you need to pause this video at any point so you could write things down, things like that, obviously do that. I'm not going to be stopping a lot and just waiting for you to work or anything. So now we have our table. Now if we look at this here, when we make one, we have the $2 and the $4 for the respective model types. Those are the corresponding terms. These terms correspond because they're both related to the same point, basically. The idea is that if there's 1, there's 2, and then $4. If there are 3, then there's 6, and there's $12. So we have these corresponding terms. So our next task is going to be to take this information and label this, graph this onto our coordinate plane here. I didn't draw the lines this time, but graph this on our coordinate plane here and to show that relationship. So we can do that kind of multiple ways. I'm going to go ahead and do that by looking at my numbers that I have here. And so my largest number for my planes is going to be $8. My largest number for my boats is going to be $16. Well, the way my graph is set up here, this is the smaller amount. So I'm going to label this as the cost of planes. So that's going to be my cost of planes. And over here, this is going to be my cost of boats. Oops, probably should spell correctly. Boats. Okay, I'm going to put a parentheses and write that as in, it's in dollars. I'll do the same down here, just identifying that we're looking at dollars here. So the idea is that when the cost of, we're going to find out what the cost of the boat is, the plane is to the cost of the boat. Well, the corresponding numbers here are 2 for the plane and 4 for the boat for one vehicle, correct? So we can really then start looking at this as coordinate pairs, can't we? P being my X, B being my Y essentially, right? So the coordinating pairs here for the first, for 0 boats is going to be right here, right? For 0 boats, so $0 for planes and $0 for boats. For 0 vehicles is going to be, the point is going to be right here. This is going to be my 0, 0, right? So the next one we're going to look at is when we purchase one vehicle, the point is going to be, X is going to be 2, Y is going to be 4. So we're going to look at 2 and 4. So that is the point for one vehicle. So 2 vehicles are going to be 4 and 8. So we're going to go over to 4 and up to 8. Now you may have noticed, I'm going to stop right there. You may have noticed that I skipped numbers here, because this is what it does in the book, but also this is another way that we can look at this, is that it doesn't mean that these numbers don't exist, okay? Just because I didn't label them. I technically don't even need the dashes there, but they exist. And that's important that we notice that, because halfway between 0 and 2 is 1, right? Halfway between 2 and 4 is 3. But we're only dealing with even numbers here, so we don't necessarily even need all that extra stuff. And even if we didn't have to go to 3 or something like that, we can still go there. It just isn't labeled. So we don't have to label every single line. It gets kind of a little bit tedious, especially when we start making larger coordinate planes, right? Also, if we have numbers that get quite large and there's a wide range of things, we can also make our numbers by 20s, if we're, by 30s, and then parts can be followed. It doesn't have to land exactly on it. As we get going, you're going to find out that it doesn't have to be exactly perfect, I guess you could say, okay? All right, so the next one. So this was for 2 vehicles. So 3 vehicles is going to be 6 and 12. So 6 here, and we're going up to 12. It's going to be about right there. About right there. Okay, so over 6, then up to 12. That's approximately right. The last one here is going to be 8, and then 8, and then up to 16. Okay, so again, there are my plotted lines there. So I'm going to go and draw a line and connecting like we talked about in the last video. I'm going to connect these lines so we can see. See how accurately I did this. Hey, what do you know? I did it right. Okay, and you can see the relationship is pretty much, I made my dots pretty much straight on, and there's a consistent growth. I guess just expense, as you buy more, obviously the price is going to go up, right? So that's one way you could do this. You could also have done this by listing down here, instead of the cost of the plane here, you could have also written this as the vehicles. So that could have corresponded, this being your X here, the vehicles could have been X, and then P and B both could have been Y, and you could have 2 different lines that go on this. So let's go and do that one real fast just to see what that might look like. So if this is my vehicles, then I'm just going to put the cost of model. So I'm just going to put cost of model here. Okay, so for one model, so now we're going to have the 1 right here, right? So for one model, let's see, for our plane, it's going to cost us 2, then 4, then 6 for 3, then 8 for 4. Okay, so that would be an example of our plane, right? And then for our boat, it's going to be 1 costs 4. So we're going to use a open circle for these ones. 4, 8, 12. I know you can't really see well. 12, and then for 4, we would go up to 16 here, about there. So I used open circles to represent the open circles. I'll make a little thing. Open circles equals boats. Filled in circles equals planes. So there's another way you can do it where you have two different, so you have each of them represented singularly, and this is represent the number of vehicles. So obviously I didn't need all this extra stuff, so I'm only going up to 4 here. So I'm going to go ahead and connect these dots. I'm going to use my ruler and connect these dots. All right, sorry. So with my 2 lines here now, as you can see, I have the open dots right here. The open dots here are the cost of the boats. The darker dots here in this line right here would be representing the cost of my planes for each one, so the number of vehicles down here. And the thing is that we could project this out obviously beyond 4. So if we bought 10, 15, it would fall onto the same line. This is going to be a constant and a consistent from here until eternity. We just made a line, a straight line that's going to go on forever and ever if we were going to top out, or if we were going to go, I guess, technically into the negative, and we were going to have negative vehicles and negative costs. But yeah. For this is what it might look like. This is two different ways we can model this and hopefully make sense of it. And we see that relationship as the cost changes, right? Now, naturally, when we look at this, we can see that for every vehicle, the boats cost twice as much, right? Because if I buy 3 vehicles, 3 planes, they cost $6. And if I buy 3 boats, they're going to cost 12. So the cost is going to be double. And you can see that here as well. At this one, each one is double the subsequent value. Now, again, I know there's no lines going across, but if you actually check this out, 2, then 4, right? The next one here would be 4, and then 8. And they're constantly doubling. You can see the exponential growth and how much more expensive the boats are than the planes. Another way to compare and see that relationship of the corresponding terms. So again, the boat and plane costs are the corresponding terms for each one here. So 2 and 4 would be corresponding, 4 and 8 would be corresponding, and likewise. So hopefully that makes sense for these different patterns. So there's 2 different patterns, but within the patterns, there's essentially a connection, a relationship that is showing those corresponding terms. So again, if you obviously want to pause the video and look at this, write this down, solve that problem and do it on your own. Practice. You have a grid already in your book that all you would have to do is kind of fill it in. Practice doing that and labeling it to make sense of it. All right, hopefully that helps. I don't know kind of where you guys are all at in your books. You know, kids are working different. My son, for example, he's finished all of the assigned math, and he's actually working on some other math now. If you have finished all the math and you are looking to do some more, I can tell you right now that you can jump into lesson 20. Let me get this right. Lesson 28. Lesson 28 and 29, I'll post this as well. Lesson 28 and 29, yes. Lesson 28 and 29 is talking about categorizing two-dimensional figures, polygons. And so that would be a good place to go as well. 28 and 29 talks about classifying triangles, rectangles, quadrilaterals, all that different stuff. So going from a general to a specific, and that would be the next step of assignments that I would have for you guys that are ready for something new. Obviously, if you're not done with this other stuff, don't go ahead yet and take your time, work through it, because I know that we all work at different paces. So again, don't hesitate to write, ask questions. Love hearing from you guys, those of you that have written. And so, yeah. Take care, all, and yeah.
We would be honored if you would join us.